Hello everyone, in this video we will see operating system design and implementation and its structure as well as virtual machines. So operating system design and implementation depends on two things. One is policy, what should be done, and second one is mechanism, how it should be done. So mechanism determines what and all which was decided to be done is like how you can implement what and all is decided to be done, and this policy and mechanism depends on the set of rules provided by local government as well. So under the implementation, most of the operating systems earlier were written in assembly level languages, and now the operating systems went to higher level languages, and it started with C, C++. Presently they are using C# also to write operating system. Actually the lowest level of operating system, the language which is like operating system written in assembly level languages, is faster and compared to the higher level language operating system, because they access directly with registers. And now the operating system is mixture of low level assembly languages, and most operating systems main programs body is written in C, and system programs are written in C, C++. And coming to graphical user interface, the operating system is developed with the help of C# and .NET, and other operating and like other programming languages and scripting languages like Perl, Shell, Python, all these are used in development of operating system. So general operating system structure is divided, like we have 4 different types of general operating system structure. The simple structure was developed for Microsoft DOS. So under Microsoft DOS structure of operating system, as a name specifies, it is a simple structure, and the operating system was only for single processing. It is not divided into multiple layers, rather it has only one application program and MS-DOS operating system. This operating system is divided based on the functionalities like resident system programming, the main system programming, which is in turn connected to MS-DOS device driver to connect to the input-output devices, and these two, the resident system programming and device drivers, are connected to ROM BIOS device driver. ROM BIOS device driver will load resident program and device driver program, and all these application programs, all the application programs runs on resident system program with the help of device drivers. Next comes traditional Unix based or Unix system structure, which is also a multi-layered structure which defines kernel functionalities and shell functionalities detail. The user is the first layer. Below user, every user will be given with a shell and a command prompt. Each shell is responsible for that user interaction, and command prompt is used for user interaction, and it also includes compiler, interpreters and system libraries. And these shells and the system functions will interact with core kernel with the help of system call interface, and this core kernel will contains all the functionalities to interact with input-output devices and the processors and file systems. So all these are interfaced with the hardware with the help of kernel interface to the hardware, and terminal controller, device controller, memory controllers are used to interact directly with hardware. Next comes layer approach. In this layer approach, operating system is divided into n number of layers, where bottommost layer is used for hardware interaction and highest level is used for user interaction. With modularity, the layer sections such as user function operation and the lower layers will be interacted one after the other. The hardware cannot be directly interacted with user, but the user interaction happens with hardware of a computer with the help of multiple layers in between. Next comes microkernel system structure, where the core kernel is divided into multiple microkernels For example, we have interprocess communication kernel, memory management kernel, CPU scheduling kernels, and these microcontrollers are responsible for execution of application programs, file system, device drivers, and when user application is executing some process, the data between each microkernel is transmitted between them with the help of messaging. So we have user mode, which is having user applications and hardware. These microcontrollers in turn connect with CPU hardware for execution. And next comes modules. In modern operating system, the modules like operating system is not loaded to the RAM completely because the size of operating system is huge, which is difficult to load complete operating system at once to the main memory. Instead, we make use of loadable kernel modules. So the object-oriented approach of writing the program and code, the writing the operating system is divided into core operating system and modules, which makes a loadable kernel module easy to execute. So we have this loadable kernel modules in Linux and Solaris models. So here we have one Solaris modular approach for loadable kernel module, where Solaris core kernel is written and all other functionalities are divided into object-oriented or class-wise, and these contains different modules. Whenever the process needs to execute these services of operating system, the module of that operating system is loaded onto the main memory based on the demand. Since these are not required for all the process, or like all the modules are not required for all the process to execute, based on the module which is needed by the process to execute, that module will be loaded onto the main memory so that the data in the main memory will be limited for operating system and you can focus on application programs rather than the size of operating system. The loadable approach makes operating system execute effectively in execution and maintenance of application programs. Next comes virtual machine. Virtual machine is one platform where it allows operating system, like many operating system, to run on one computer as a native compiler. We have an example of VMware where you can have multiple operating system running on the native operating system as a guest. So this virtual machine manager is used for providing virtualization services. And one more example of virtualization services is Java Virtual Machine. First we have virtualization, where one kernel, instead of having one hardware with one kernel, there will be multiple operating systems. There will be multiple operating systems loaded on one virtual machine, and they access each and every operating system access native operating system when they are logged in. Like how we load multiple operating systems on one computer. So hardware is divided into virtual machine manager, that is our virtualization. Each virtual machine manager will be loaded with one operating system or one different kernel like Windows, Linux, or Fedora, Mac, and so on. Next we have virtual machine or VMware, where there will be one CPU, memory, and hardware which is installed with one operating system called host operating system, or we can call it as native operating system. This native operating system is installed with virtualization layer of software called VMware. This virtualization layer can adopt or can install with multiple operating system, which helps to feel like there is virtual CPU memory devices provided to each and every operating system, where in VMware Architecture, in turn this virtual CPU is the only CPU which is working on the system, and this native operating system allows another operating. Next we have Java virtual machine architecture, where in Java virtual machine architecture, the host system can be any operating system. The Java files will be loaded with a class loader with the Java API files, and Java interpreter converts the Java source file into executable file which can be executed on any platform or any operating system irrespective of the type. So say one Java program with the help of Java virtual machine can be executed in all the types of host system or all the types of kernel system. So we call it as Java virtual machine. I hope you understood these topics. Thank you.